This next section is on measures of center, specifically mean, median, and mode. There's a few spots in this lecture where I'm going to want to go and do some problems out on a whiteboard for you. So when that occurs, I'm just going to kind of wave my hand and then cut in the parts of me doing work on a whiteboard. So just to define what these three terms mean, the mean is the sum of all the data values divided by the number of data values. Normally it's called an average, but mean and average mean the same thing. Basically, I just look for what, if I add them all together and divide by how many they are, what's the average? For median, it's the middle value in an ordered array of data. Basically, if I line everything up from the smallest data point to the largest data point, it's what occurs in the middle of all the data points. Mode is the value in the data set that occurs most frequently. So the thing that happens the most often is the mode. We're going to talk about different types of mode. If something's unimodal and has only one mode versus bimodal, multimodal, no mode. But in general, the mode is what's happening the most often. The general formula for finding the mean is x with a little line over it, which we're going to call x bar in this class from now on, equals each of the individual data points. So x1 is the first data point, plus x2 is the second data point, plus so on, until x sub n, where that little n stands for the total number of data points that we have. It's another way of saying it is the sample size is that little n. So I need to add together all the data points on the top of the equation, and then divide by little n, or how many data points I have. If, for instance, the data set I had was 7, 8, 3, 9, 2, 3, 10, 6, I'd want to add together each of these numbers on top and then divide by how many data points there were 8. So if I added all of these numbers, I would get a total of 48. 48 divided by 8 is why I get a mean of 6. When you want to find the median, the first thing you want to do is order everything smallest to largest. So here what we've done is taken the unordered data set that was in the previous mean slide, 7, 8, 3, 9, 2, 3, 10, 6, and we've now reordered it, 2 being the smallest, then there's 2 3s, then 6, 7, 8, 9, 10. So we now have it in order from smallest to largest data value. Once we have that ordered list, we can use the next formula to identify the location of the median. There's going to be some of these formulas that result in telling you the location, and some of these formulas that result in telling you positions, where a lot of students get confused and think the answer is what the formula tells you. To be clear, this formula tells you where to look. It does not tell you the actual answer. After doing this first formula and figuring out where to look, that's where you find the actual answer to these problems. So the formula is, to find the position the median is in, I add how many data points there are plus 1, and I divide by 2. In this case, since there's 8 data points, the position is 8 plus 1 divided by 2. 8 plus 1 is 9, divided by 2 is 4.5. When you have an odd number of data points, it's always going to give you a whole number median. It's going to tell you the specific position, either 4th position or 5th position. I can just go to my ordered list, count over that many, and stop where it is, and that is the correct median. When I have an even number of data points, like I do here when I have 8 data points, the position formula is going to give you something 0.5. What that really is telling me is I need to take the 2 data points closest to that and average them, or add them together and divide by 2. So when I have an even number of data points and get 4.5 here, that's between the 4th and 5th data point. So if I count over 1, 2, 3, 4, the 4th data point is 6, 5, the 5th data point is 7. So what I need to do is add 6 plus 7 and divide by 2 to find the median. 6 plus 7 divided by 2 gives me 6.5, which is the median. You'll notice that 6.5 is not a number in the data set. The median does not need to be a number in the data set. It always will be a number in the data set if you have an odd number of data values, and there's times where even if you have an even number of data values, the average is a number in the data set because the same number is right next to each other. But in general, when you have even data values, you can absolutely get something outside of the data set as the median. Last thing we're going to look at for this first example is finding the mode. So you don't need to put everything in order to find the mode. It's possible you can look at this list of numbers and say, hey wait, 3 is happening twice. The only thing that's happening twice, it's what's occurring most frequently. But since we already ordered everything to do the median, and in general you're asked to do all 3 to the data sets that you're given, I might as well use the ordered data set to see, yes, that's correct, 3 is the only thing that happens twice. It's not entirely necessary, but it's easier to identify if you go least to greatest. Here's the way that the mode could be expressed. If I have no repeating numbers, so if this was my data set where every number is distinct from every other number, in that case I would report no mode. There is no most frequently occurring number because everything only occurs once. As opposed to, if I had this data set where I have 6 occurring twice and nothing else occurring twice, that would be something that's unimodal. Uni meaning one, modal meaning mode. So since there's only one number that repeats the most frequently, it's a unimodal distribution with one singular mode. Now, where students sometimes get confused is they think that it just has to repeat it all. That's not correct. It has to be the most frequent. So if, for instance, I had 2 3s, 2 8s, and 3 6s, only the 6 would be the mode, the thing that occurs the most frequently. So it's not just a number has to repeat. It has to repeat the most times of any number in the data set. That said, there could be a time where 2 different numbers both repeat the most amount of times available. Specifically here, 3 happens twice and 7 happens twice. Since 2 different numbers both happen the most frequently, this is a bimodal distribution. Bi meaning 2, modal meaning mode. So in this case, you would report that it's bimodal, and specifically you would say the mode is 3 and 7. The final example, multimodal, you'll see that 3 repeats, 7 repeats, 10 repeats. So because there's 3 different numbers that happen the most frequently, all 3 are the mode, I would report the mode as 3 and 7 and 10. Again, whenever you have a situation that has more than 2 modes, you call it multimodal. So in this case, multi just means many, modal means modes. So that includes if you have 3 modes, 4 modes, 5 modes, any number greater than 2. So to recap, if nothing repeats, no mode. If one thing repeats the most frequently, unimodal. If 2 different numbers repeat the most frequently, bimodal. And if more than 2 repeat the most frequently, multimodal. I'm now going to ask you to find the mean, median, and mode of these 3 data sets. I'm going to go ahead and wave my hand here because I'm going to do it on the whiteboard in a second. For each of these 3 data sets, the first thing I want to do is reorder the data set, put it from smallest to largest. It's absolutely fine if you found the mean without doing this, but I know I need to do this for the other steps. So I'm just going to do it right away. So my reordered data set, I look across, I see the smallest number is 5, then 6, then 8, then 10, then 13, then 18. At this point, I always like to double check that I have all the numbers I'm supposed to have. So in the original data set, I had 1, 2, 3, 4, 5, 6 points. In the reordered data set, I have 1, 2, 3, 4, 5, 6. I'm then also going to note n equals 6 when I do that check. If I now go to find the mean, I'm going to add together all of these numbers on top. So 5 plus 6 plus 8 plus 10 plus 13 plus 18. And I'm going to divide by how many data points there are, specifically 6. There's an understood parentheses on top here, saying that we have to do all the addition on top before we do the division. I'm going to be using this calculator just because it's the one I always use for calculus, other things like that, and I have it. Don't feel like you have to pay the $100 that this thing costs, or maybe you can get it used for like $20, $30, unless you're planning to go on to calculus and other things beyond this class. For the sake of this class, you can absolutely get by with the TI-30, which I believe costs about $10 to $15 if you buy it either at Staples or Amazon or something like like that. But basically, you do not need this type of calculator, so don't be scared when you see me using it. That said, I'm going to put in parentheses 5 plus 6 plus 8 plus 10 plus 13 plus 18, and I get a total of 60 when I add them all together. If I then divide that by 6, I get 10. So I get a mean of 10 for this data set. Again, I want to get you used to the notation you're going to see, so really I'm going to call this x bar, or the mean of a sample. Next thing I have to do is find the median. To find the median, I'm going to use my median formula to find the position. So the median formula tells me I'm going to take n, in this case 6, plus 1, and divide it by 2. That gives me 7 divided by 2, or 3.5. Again, this formula tells me where to look. It doesn't tell me the answer. So a lot of students get confused and they think the median is 3.5. It absolutely is not. 3.5 tells me that the median occurs between the third and fourth data point. So this returns a position, not an answer. When I look between the third and fourth data point, I'm going to make sure I'm on the second reordered list, not on the original list that was out of order. So on this reordered list, 1, 2, 3, this is the third data point. 4, 5, 6, this is the fourth data point. So between the third and the fourth data point means I take the third data point, 8, I add the fourth data point, 10, and then I divide by 2. That gives me 18 over 2, or 9, which is the median. Last thing I need to identify is the mode. In this case, as I look across the numbers, I don't see anything that repeats. So I'm going to say that the mode is no mode. This is different than 0. If you tell me 0, you're telling me 0 is the most common number. 0 is a number, and it's possible you could have a data set where 0 is the most common number. That said, no mode means nothing repeats. It has to be said in that way. You have to type out the words NO space MODE if you want to declare that something has no mode. That brings us to data set 2. Again, we're going to start by reordering. So I see that 1 is the lowest data point. There's 2 of them, so I'm going to write 1, comma 1. Next data point I see is a 2. Then I see 12, 13, 14, and 15. Again, after I write something like this out, I want to double check that I didn't miss any of the points. So in the original data set, I had 1, 2, 3, 4, 5, 6, 7 points. In this data set, I have 1, 2, 3, 4, 5, 6, 7 points. So I feel good about it. I'm going to write down what that n is for use of my formula, n equals 7. I'm now going to calculate the mean. To do that, I'm going to add together 1 plus 1 plus 2 plus 12 plus 13 plus 14 plus 15. I'm going to take that answer, divide by 7. So when I add these all together, 1 plus 1 plus 2 plus 12 plus 13 plus 14 plus 15, I get a total of 58. When I divide 58 by 7, I get an answer of 8.2857, 14286. I'm writing all those digits up there to show you not to do this in the future. Basically, I could always write all this if I wanted, but it's too much information, if anything. My general rule of thumb is, if the original data set is whole numbers, when I go to calculate the mean, I'm going to go to 1 decimal place beyond where the original data set is. So my normal way of doing this is saying, if I had whole numbers, I'm going to round to this decimal place. Since it's 8.28, the number after where I'm rounding is 5 or larger, meaning I have to round up. So I would report this as 8.3. It'd be fine to report this as 8.29 or 8.286. There's other ways you could round this that might make sense for a given situation, depending upon how much your tolerance was for these decimals. But In general, you want to go at least one spot to the right. So if they're whole numbers, I wouldn't round this down to 8. I'd at least report it as 8.3. Hopefully I'm going to try and stick to that convention in general, but there's definitely times where I just jump to going to 2 decimal places because I'm really used to using that with dollars and cents and in other contexts. So you might see times where I don't obey my own rule and I go to 2 decimal places. For WebAssign, they almost always tell you how many decimal places to go to. If it doesn't say in parentheses, round your answer to 3 decimal places, it means they want the whole thing. But in general, when it's a number that's going to have this much decimal, they tell you to round to a certain number of places. Continuing on, finding the median, again we start with the position function. So n in this case is 7 plus 1 divided by 2. That gives me 8 over 2, which gives me 4. When you get a whole number for the position function of the median, it means there's an exact median which is in that spot in the ordered list. So 4 means the 4th spot in the ordered list. 1, 2, 3, 4. 12 occupies the 4th spot in the ordered list. So the median equals 12. As I look across, I see 1 repeats. Since nothing else repeats, that is my mode. If I was asked what type of mode is this, it would be unimodal. In other words, one mode. When I get to the final data set, again, I'm going to start by reordering it. So here I see the smallest number is 3. And then I see an 8 and another 8. Then I see a 10. Then I see a 14 and another 14. Then I see an 18 and then a 20. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So n equals 8 here. When I go to find the mean, I'm going to add together 3 plus 8 plus 8 plus 10 plus 14 plus 14 plus 18 plus 20. And I'm going to divide all that by 8. When I put this into my calculator, 3 plus 8 plus 8 plus 10 plus 14 plus 14 plus 18 plus 20, I get a total of 95. When I divide that by 8, I get an answer of 11.875, which I would call 11.9, but I know in the next slide I call it 11.88, so again, I don't necessarily follow my rounding convention as much as I would like, but what I've been told from other books and what I like to be able to say is that if it starts in whole numbers, go to at least 1 decimal place. I now have my mean. Next thing I need to figure out is my median. Again, I'm using the position function that tells me I should be taking n, which is 8, plus 1, dividing it by 2. That gives me 9 divided by 2, or 4.5. As I count over, 1, 2, 3, 4. The 4th number is 10. 5. The 5th number is 14. So I want between the two, that's why I take 10 plus 14 divided by 2. That gives me 24 divided by 2, which gives me 12. 12 is the median for this data set. Finally, when I look for the mode, I see that 8 happens twice and 14 also happens twice. That's why I would report the mode as 8 and 14. If I was asked what type of mode this is a bimodal situation because there's 2 modes. I'll do it on the whiteboard in a second. This should be what I end up with. So for the first data set, we got a mean of 10, a median of 9, and no mode. For the second data set, we got a mean of 8.29, a median of 12, and a mode of 1. And for the third data set, we got a mean of 11.88, a median of 12, and a mode of 8 and 14. So looking back to how we described different skews, it is important, I should say, to understand how these skews impact the median, the mean, and their relative positions. So when I have a symmetric, mound-shaped, bell-shaped, normal curve, any of those words might be used to describe it. That occurs when the median is in the same spot as the mean, right in the middle of the distribution. In order to have left skewed, that means the data is piled up on the right. The reason it's called left skewed is because the skew is concerned with the direction the mean is pulled. Because of this longer left tail, the mean is pulled to the left and will be further left than the median when the data is piled up on the right. So in a left skew, the mean will be less than the median. The opposite is true in a right skew. In a right skew, you have the longer right tail, which pulls the mean to the right. So in a right skew with the data piled up on the left, the mean is to the right of or larger than the median. Determine the shape of the following data sets. So these we already found the mean and median previously. We're now just saying, let's look at the two of them and say what type of shape we're seeing. So in the first one, the mean 10, the median 9. The mean is larger or to the right of the median. For that reason, this has a right skew. Remember, the skew goes in the direction of the mean. Here we have a mean of 8.29, a median of 12. So this data set has a left skew. It has a left skew because the mean is less than the median. For the final data set, we have a mean of 11.88 and a median of 12. I'd be alright if you told me this has a slight left skew. That is correct. But truthfully, these are close enough that you'd probably report it as symmetric. There's definitely a problem that came up in the homework where students asked me a question about it saying, wait, why isn't this skewed? There's this extra dot on the left, shouldn't it be skewed to the right then? And truthfully, it was a slight skew, but for the most part, the numbers were close enough that you could have called it a general symmetric distribution, which is what they wanted as an answer. So I absolutely understand if you're telling me this has a slight left skew, it does. They're close enough that you would probably say it's a symmetric distribution. So here are my answers. Again, symmetrical or slight left skew here, either is a reasonable answer to that question.